When you are working with fractions, you have to remember how we write it. Don't forget how you write a fraction, again, like 1 over 2. The first fraction you would probably learn about is the word half, but you learn it as the word half, but you certainly don't start writing it like this until long after that. And as I said earlier, you probably just learn that half means part of something. When you first learn that word, when you first learn the word half, you don't, if you ask a 2-year-old who's used the word half, they don't say, oh, take something, break it into 2 equal pieces, and then take one of those pieces. They won't use the word equal. They'll say, the word half just means break something into 2 pieces and you get one of them, right? You get a part of something. They kind of think it means the word part. If you use the word 1/2, especially when you write it as a fraction, we're talking about take one whole object and take half of it, right? The thing to remember with fractions, no matter what the fraction is, if you're writing one number over the other like that, this number represents the number on the bottom is called the denominator. I don't really care if you know that word or not, but what I want you to know is that the word denominator, the bottom number represents, if you're just doing it in everyday words, it tells you how many pieces you broke your, let's say again, this is a cookie, right? Here's your cookie. You're going to share it with your little sibling. The 2 represents how many pieces you broke the cookie into, right? So we broke the cookie into 2 pieces. This is number of pieces you have, right? Number of pieces in one whole. One whole, I'm not going to put the word cookie here, but you could say the number of pieces in one whole cookie, or whatever, right? One whole object in one whole thing. The top number doesn't represent how many pieces are in one whole thing. It represents how many you have, right? If you say you have 3/4 of something, again, what does that mean? If you say you have 3/4 of something, it means out of the 4 pieces that there are, I have 3 of them, right? I'm not trying to insult your intelligence here, but we forget as we get into grade 7 and 8 and working with fractions and adding them and making common denominators and stuff, you forget what fractions are. The bottom number is how many pieces one whole object has. The top number is how many you have, right? It's number 1, it's called the numerator if you want to know the word. But it's how number of pieces you have. If I say you have, it doesn't sound very mathematically proper, but number of pieces you have. Number of pieces you have and how many pieces there are altogether, right? When you talk about having 3/4 of something, out of 4 pieces, you have 3. If this was a mark on a test, what does this mean? If this was a test mark and it was not a very big test, I guess. Yeah, it's equal to 75%. 75% is just making into a fraction out of 100, right? 75 out of 100. If you say you have 3/4, you got 3 out of 4 in the test. Out of the 4 marks or questions on the test, the number you got right was 3. You have 3, the whole test has 4, right? That's all it's saying. You got to remember that as we work with fractions. The first thing you're asked to do when you work with fractions, grade 6 or 7, is you look at making what are called equivalent fractions. What does the word equivalent mean? Equal. Basically, it means equal, right? If 2 things are equivalent, basically they're equal. Equivalent fractions. A fraction like 1/2, you can write, we're going to make it's not going to be a cookie, it's just going to be a bar here. It's going to be we'll make it like that, okay? That is, I don't know what it is. It's just a piece of paper, a strip or something like that. If you want to represent the fraction 1/2 with a strip like this, you can tear it into 2 or cut it into 2 or draw it as two spots. And then how many do I have? I have one out of the 2, right? But there's other ways you could do it, right? You could take that same thing. Instead of taking one whole strip and breaking it into 2, I could copy and I could paste it down here. Okay, and then instead of having 1, I'm going to leave the shading there. Instead of breaking it into one piece and I don't know why it's doing that. I could cut it into, kind of weird that it's showing it like that. That's okay. You could break it into 8 pieces. How many do you have out of 8? You have 4 out of 8. Or you could call it, move that up there. Or I could have drawn it as, I could have had my rectangle like this. I won't try to copy and paste. It took longer and it didn't even work anyways. I could cut it into 4, and I could say I have 2 of those 4, right? Those are all equivalent fractions. What's the last one called? Out of the 4 pieces that I cut the strip into, how many do I have? How many did I shade yellow? Out of the 4, I have 2. When you're writing fractions, I know when you're writing on a piece of paper, you usually start where? You start in the top left. So it tends to be when people like to write fractions, this is how they like to write them. They like to put the top number and then the bottom number. I think it's better if we write the bottom number first always and then the top number. This is how many pieces there are. This is how many pieces you have. These are all equivalent. Although, again, my picture didn't work out very well with this. This is very strange how that's happening. We're going to redraw that one. These 3 fractions are equivalent. Not that this is, you don't buy pizzas that are that shape, but if you ordered a pizza and you cut it into 2 equal pieces and you ate one of those pieces, or if you ordered a pizza and cut it into 8 pieces and ate 4 of those pieces, or if you cut it into 4 pieces and ate 2 of those pieces, you've eaten the same amount of pizza regardless, right? You might feel better because you might say, again, when you're 2, before you understand that the pieces are different sizes, you might say, I ate 4 pieces of pizza. Oh, I only ate 1. You know, if they're different sizes, it makes a difference, right? These are all equivalent. They are the same amount. If you get 1 out of 2 on a test, or 4 out of 8 on a test, or 2 out of 4 on a test, it's all 50%. Writing something as a percentage is just making it an equivalent fraction out of 100. That's all percent means, out of 100. Okay, so it's really an equivalent fraction as well. If you want, somebody might have taught you to write equivalent fractions. Like if somebody gives you a more complicated or, with bigger numbers here, and somebody says 7 out of 13, and somebody says, what are some other fractions that are equivalent to that? What's another fraction that's equivalent to that? What's another fraction that's equivalent to that? What do you think? 14 over 26. Absolutely. I want you to think carefully about what that would mean up here. That would be like taking this fraction and turning it into this fraction. You're just doubling the number on the top and the bottom. This was 1 out of 2. If you change it to 2 out of 4, you're just doubling the number on the top and the bottom. We can times this by 2 as long as we times that by 2. I want you to realize what you're actually doing with the concrete model of the thing here. What you're doing is if you take a fraction like 1 out of 2, I should have put this in a better order. If we had to put this in an order that makes sense, don't you think this one should be underneath the other one here? Why should that one be underneath that one? Why should that one be there? I'm going to switch the order of them because that's a better order. Yeah, this is lowest terms. This is kind of the largest terms you can work with here. If you jump from one to the other, this is multiplying the top and the bottom by 2, and then multiplying the top and the bottom by 2 again. What that means concretely here with the model is multiplying the top and the bottom by 2. Think about what it means. Remember, the bottom number is how many pieces you have. Is that true? That's not true, is it? That's not how many pieces there are altogether, right? This is like if you ordered the pizza, that's how many pieces there are. There's 2 pieces and you're taking one of them. If you take 1 out of 2 and you say, I'm going to times this by 2 and times this by 2, it's like taking this and saying, I'm going to cut each of the things in half. I'm going to cut all of the pieces in half and the number and the pieces that I have. I'm going to cut everything in half. That's what you're doing here. Instead of saying 7 out of 13, you're changing it to 14 out of 26. You're cutting all the pieces in half and making the pieces smaller. You're making the pieces smaller because there's more of them. but you're taking more of them. Would you rather have 14 26ths of a pizza or 7 13ths of a pizza? Only. Would you rather have that much or this much of a pizza? Doesn't matter, they're both the same, right? That's the right answer, right? It doesn't matter, they're both the same. Unless you decide, well, I want to feel like I have more, so I want to have more. I want to have twice as many smaller pieces, right?
Or if you have like 26 people over.
If you have 26 people over, absolutely, you need it to be like this, right? Let's draw it round because I'm not going to cut it into 20. I'm not going to cut it into 26 pieces, but because it's going to be pretty hard. But if you divide it into 2, that's a pretty big piece of pizza, of course. And you take one piece, it's the same as if you divide it into 4 pieces and take 2. Or you divide it into 8 pieces and take 4, right? When you're changing the terms that it is from 1/2 to 2/4 to 4/8, you're just changing how many you have. You're just changing how many pieces there are. Is the amount of the thing that's shaded up here any different in any of them? There's still the same amount, same fraction of it. Are you paying attention? No? Grade 7, you learned to do adding and subtracting, right? Add and subtract fractions. You learned to add and subtract fractions. I would like you to be able to do it with a concrete model, like with fraction strips or with some kind of way of modeling it, but I'd also like you to be able to do it by writing it, writing the fractions. You probably, the first adding fractions you did when you were a little kid was 1/2 plus 1/4. And I want us to think through, I know that this is pretty easy, but I want you to think through and realize it's not any harder when the numbers get different. It's the same concept. What does that add up to? 3/4. Why is it 3/4? When you're a little kid, you don't do what your teacher told you to do in grade 7. Your teacher in grade 7 probably said something like, if you're adding these 2 fractions, you got to change one of them. You have to change this one. What do you need to change that to? You need to change you can change the 1/2 to, what can I change it to? I'm going to write, you can change it to 2/4. That actually is what you did when you were a little kid, but you didn't write it like that. You just thought, 1/2's like 2/4, and then I got another 1/4, so I got 2/4 and 1/4, so I got 3/4. That's all you're going to do for adding or subtracting fractions now is, if the pieces are different sizes, so we'll use the circle model again, you can use a whole bunch of different things to model fractions. You can use circles, you can use strips, okay, like rectangles up above. You can use those pattern blocks that we'll use at some point here. If somebody said you have 1/2 of a something, and you have, I'll draw another one here. I'll draw it separately because we haven't actually added it yet, so I need another circle over here. So in one box you have 1/2 a pizza, and in the other box you have 1/4 of a pizza. Okay? Yellow pizza, but you got that, right? And someone says, altogether, dump that into one box and tell me how much you have. If you put all that together in one box, how much do you have? 3/4, right? All you're doing when you change this to this, when you make that change from 1/2 to 2/4, is you're saying, visually or concretely, what you're doing is you're saying, I'm going to take these 2 pieces, I'm going to cut them each in half. Now I have, instead of 1 out of 2, I have 2 out of 4, right? 2 out of 4 is the same as 1 out of 2. But why does that help? Why does it help changing this to this? Before, the pieces are not the same size. When you're a little kid and you're 2, and you say, ooh, look, in this box there's 1 piece of pizza, and in this box there's 1 piece of pizza. So I have 2 pieces of pizza. But they're different size pieces, right? I don't know what that was, but that wasn't how a little kid talks. But that is definitely not how a little kid talks. I don't know, that was a cross between something, but you have a little kid and some strange evil villain from something, but you have 1 piece of pizza over here, you have 1 piece of pizza, they're different sizes. You can't add them if they're different sizes. You need to make them the same size first. So you do that, right? as soon as you make them the same size, then you can put them all in the same box and say, how much do I have here? Well, I can't turn this around, but if I could turn that around, it would fit in there. I'll just throw that away over there. I guess I'll just delete it and redraw it without you seeing. Look, I rotated it and fitted it in there. So you got 3/4 now, right? If you have one where you might have it where it's not so easy to do, right? Like 1/3 plus 1/2, and you say, I don't want you to go backwards from what you knew when you were a little kid. A little kid they think through this and they come up with 3/4, but somehow when you learn all these rules and somebody's got to, make common denominators and all this stuff, I get a very wrong answer. What do you think the most common wrong grade 8 answer to that is, or grade 7 answer? 2/5. It's definitely not 2 out of 5 pieces, right? If you draw the circles and do it, it's definitely not. I'm going to use rectangles for this. I'm going to use fraction strips for this. I'm going to make them this long because I know what I have to do with this. So I'm going to make one like that, and I'm going to make another one like that. The first fraction is 1/2, right? No, it's not. It's 1/3. First fraction is 1/3. I'm going to divide this into 3 pieces, and I'm going to shade one of them. The second one is 1/2. I'm going to make it into 2 pieces and shade that much. Out of one whole rectangle here. So here's where my answer is going to be. What I have together. When you first learned to add things, they told you to just lump them together and count it all up, right? If I shade that much down below here, how much do I have? If I take these, I'll actually take these pieces and move them, right? If I take this much, that much shaded, okay, and I put it down here, and I take this much shaded, and I put it down here. Except my lassoing skills aren't seeming to work right now. And I put this down here. How much do I have shaded out of that? I have how much? How many? You want me to count them for you?
5, 6.
5, 6. Again, not trying to insult your intelligence. I want you to be able to get there without having to draw the pictures eventually, but I do want you to be able to connect how to get there with the pictures. How to get there concretely or by writing the fractions is to change the things, right? We started with one of these and one of these. What you're changing is you're saying, I need to cut them all into the same size piece first, and then I can add them together. If I split it up like that, what am I doing? I'm changing 1/3 into, what am I changing it into? I instead of having 3 pieces, I cut it up into 6, and I'm saying, how many do I have now? Instead of 1/3, you're changing it to 2/6. Instead of 1/2, you're changing it to 3/6, right? So you're saying I have 2/6 plus 3/6 is 5/6. Try not to do this by learning rules and memorizing and saying, oh, I got to do this and multiply that and put these numbers over there and whatever. Like you were looking yourself in the lap there, but how do you get this number from this? How do you get that number from that? Obviously, these two numbers. Once I cut it up, I have 2 pieces and 3 pieces. I got 5 pieces. Do I add those together? Because here's the second common wrong answer. Instead of 5/6, the wrong answer would be 5/12. Why do you not add that together? The bottom number just says how many did you cut one whole thing up into, right? One whole thing up into. We're doing the pizza example again. There's 2 pizza boxes here, but you're always comparing it to how many pieces are in one pizza, right? If you cut them into smaller pieces, one pizza would have 6 in it, and you have 5. You almost have enough to make a whole pizza if you shove those 2 boxes together. For adding and subtracting fractions, you do this. You make this is called, these have the same denominator. Okay? You write the 2 fractions with the same denominator. Okay? Write both fractions with same denominator. Using same denominator. Then add the top numbers. Okay? The only adding and subtracting we have in the booklet is the get ready at the beginning. There's a lot of differences. It starts in this place and it shows you strips and rectangles and things like that. But it gets up into doing things like this, 1 1/2 plus 2 1/3 or something like that. I would say to you that even though you might be able to say, oh, that's going to be 3 and something, I think your safest plan is to change these into what are called, do you know what these fractions that you can change these? These two fractions are called mixed numbers. Why are they called mixed numbers? Why are they called mixed numbers? And a left. Yeah, there's a whole number and a fractional part. They're mixed, right? It's part whole number, part fraction. It's better if you can turn these. It's probably easier if you can turn them into what are called improper fractions. Do you know what an improper fraction is? What's an improper fraction? Where you have more, right? 1 1/2. How many halves do you have if you have 1 1/2? You have 3 halves. You probably learned a rule that someone said, because when I ask people about improper fractions, sometimes they say, oh, that's the thing where you go this times this plus this. And you might have got that rule made for yourself that you do this times this plus this. But you should understand what you're doing, right? 1 1/2 is like 2 halves plus 1 half. Right? 1 is like 2 halves. It's probably safer for you, first of all, to change mixed numbers to improper fractions. I think that's the best plan. You can do it without changing it if you want. But I think, especially when you start doing some subtracting, it's hard if you try and subtract them by leaving them as mixed numbers. I'm okay if you want to teach yourself to do that, or if you already know how to do that. I think it's easier if you change them to improper fractions first. Okay? Can we get going on that get ready and working with it? When you get to the very last thing, number 6 on there, make sure you talk to me. I want to make sure we're writing, kind of showing our work in a logical way. If it's a bunch of scribbling, I'm going to make you erase it and do it again. Okay? That's you can't. I better stop this so nobody knows what I'm talking about.